Evening, everyone. As usual, we will wait for a couple of minutes for everyone to join. And as usual, let me know if you can hear me well and if you can see the presentation, if everything is fine, and if we are good to go. The previous task, I believe, was actually a bit more complicated in comparison with the previous tasks. So yeah, but I hope you succeed with this one. And if you did, so I think the rest of the tasks, so number 9 and 10, will be relatively easy for you. And especially if you're talking about the task number 9, it will be actually not a big deal to deploy this one, just because we already have the working application, and all we need to do is just to switch from Lambda function to the Docker container. And actually, that's it. But today we will actually also talk about the Elastic Beanstalk, which is an AWS service which helps us to deploy our application. And a bit later we will have a look on how AWS can help us with application deployment. So let's kick off, and as usual, let's have a look at the agenda. It's as usual quite neat. So we will talk about the Docker a bit. Next, we will have a look on what AWS, it's EBS, but it's Elastic Beanstalk. Yeah, I'm sorry for this abbreviation. It should be Elastic Beanstalk. And in the end, we will have a look at the task itself. And first of all, I think let's start from the schema. So this is actually the same one we've been looking at the previous time. So it's just a piece of our application which is responsible for the card of our web service, of our web store. But this time we will deploy it not in Lambda, but as a Docker container. So, and sure, you may say that we can actually just create a virtual machine and deploy the Docker container in it and expose the necessary ports. But likely, AWS provides us a special service which to which one we can just, let's say, feed in our code and say, okay, just deploy this one. We will only need to choose the language, the programming language on which our code is running, or if it's Docker container, we will say, okay, just run this Docker container, and that's it. And AWS will take care about the rest. So it will create a necessary amount of virtual machines, and if it's necessary, it will also create a load balancer to make our application up and running. It will also expose the endpoint of this application. And what is the killing feature, I would say, is that AWS will be also responsible to scale the resources which is necessary to run our application. And we can even manage the parameters which we will have a look at when we will make the decision about the scaling of our application. So, but first of all, let's talk a bit about the Docker. So Docker is a virtualization technology where we can just create a, let's say, kind of virtual machine and just run it with underlying operating system and with all of the necessary stuff which is necessary only to run in our application. So there should be nothing in this Docker container should be nothing which is not necessary. So Docker container usually should be as small as possible, just to make it less resource dependent and lightweight as possible. So, and at the left side of this picture, you can see the container structure. So actually the containerization structure. So first of all, we have the infrastructure, and under the infrastructure, you can understand something like your laptop. So it may be HP, Mac, or Dell, or just whatever. Next, we have the host operating system. So it may be Windows, it may be Mac OS, or any Unix systems. the rest of them. And above of it, there is a Docker. So Docker actually is the name of the software. But under the Docker, you can also understand the containerization. So the idea of containerization. So from another perspective, it will be something like another application. So we are just starting it, and this application just gives us an option to run these containers. So to run these small virtual machines, which will live only. Actually, it's like Lambda functions. So we will live only when something is running inside of it. So you can, for example, run maybe a ping command or just something like this. But in this case, your container will just start, make all the necessary stuff, and then just disappear, and that's it. But if you are talking about the long-running applications, let's say, so like in our existing application, web store. So this web store is actually maybe also running on the Docker container. So we can just run this Docker container, and it will live until we not shut it down. But from our end, we will need the Docker container to create the card API part of our application. So it will just live always, and we'll have this stable connection to our database, and we will not need to create trigger all of these Lambda functions every time we need to create another card for another user. And on the right side of the screen, you can see the Docker file, which is actually let's say a manifest which describes what kind of not what kind, but what do we need to have, what do we need in our container to have inside of it. So first of all, we are saying from node.15 as build. So we'll create from the existing node 14th image, and we will create, we will assign a work dir, so where we will work, and then we will store all of our files. When we will copy the package.json just to satisfy all of our requirements. And then we will run just npm install. So it will be necessary just to build in our application, just because we have lots of dependencies. So this command will be responsible just to build in our application. And then, at the next part, we will also copy all of the files from our existing environment to the image. And then we will build it. We will install dependencies, and then we will build in our application. And next, once again, from the node 14th, so we will create another container. And right now, this container actually is empty. So we have the previous one, which is called build. From the first line, you can see what we created in container, and then we called it build. And in the middle, we also have the from node 14th. So we created a new container. Once again, we are assigning the working directory, where we will work and store all the necessary files. And then installing all of the necessary dependencies, I believe. And then we can copy only the necessary stuff from the build container. So the one which we've been using previously. We copy all the necessary stuff to our new, freshly created container, and when we are just exposing the port number 4000. So this is the port on which our application will listen. And at the end, we are just starting in our application by running node dist index.js. So this is it. This is quite a simple example on how can the describe what kind of image we want to create, and then what kind of containers we would like to build from these images. And this approach, when we are calling two containers in one, let's say Docker file, gives us an option to get rid of all of the not necessary stuff. So we are getting rid on all of this of all on our code, of maybe some, I don't know what else can it be. So maybe some cache or something like this, just whatever, we will take to the next, to the freshly created, to the new container, only in our application, only what is necessary to make our application running and nothing else. So it gives us an option to build not a huge containers, but the small and neat ones, which you can even, which you can store on some registries and just run them as it's necessary. But actually, where is Elastic Beanstalk at this approach? So let me share my screen and okay, yeah, as usual, I need to remove this one and create this one. So what Elastic Beanstalk gives us actually, and why does it pretty, I would say, cool feature and cool service from the perspective of the AWS. So first of all, we have a virtual machine. So let me make it transparent and let's call it just virtual machine. So we can even maybe not call it a virtual machine, so it may be any kind of computer. You can even run it on your local PC, this container, but right now let's talk about the virtual machines. So let's make it like this, and where can I, okay, yeah, here we go, so top left. So this is our virtual machine. And on this virtual machine, we will actually just install the Docker, and it will be all what is necessary to make our application up and running. So let's imagine that this virtual machine also have an IP address, so we can anytime when this container is running, we can just reach this IP address, external IP address, and just reach in our API of our application, or just something like this. So, okay, I don't know why, but it looks so weird. Let me just maybe copy and paste it like this and put it on the front. Okay, yeah, and let's call this one Docker container. So you can even achieve it by creating a virtual machine by manually in the AWS, and then just install Docker in it, and then just run Docker by running Docker run, expose the necessary ports, and just provide the URL to your desired image. This is it. But what actually Elastic Beanstalk gives us? So first of all, we don't need to provision any infrastructure. So all of the virtual machines and all of the load balancing stuff, all of it will be responsibility of AWS. So we will create virtual machines for us. We will even scale it. But first of all, okay, let's have a look. So imagine today, as usual, you have, let's say, for example, 10 customers or something like this. But tomorrow, when it will be 10,000, and your virtual machine will just die just because it can't handle all of the requests, all of the load, what this 10,000 people will create to against your virtual machine, against your application in this case. But if you're talking about the Elastic Beanstalk, so first cool thing that it has is a load balancer. Do I have any assets? Yeah, here we go. So let it be like this. So we will stick this one together. Yeah, like this. So right now we have a load balancer. So first of all, when we are telling the Elastic Beanstalk to create in our application, we are telling what we want. Do we want to create? Do we want in our application to be running on a single node, or should it be something which is hidden behind the load balancer? And what this option gives us actually. So first of all, when they have 10 customers, so it's okay. So we have just one virtual machine and Docker running inside. But once the load will rise, AWS will understand that, okay, we need to do something with it. And it will just create another virtual machine by itself with another Docker installed on this virtual machine. And Elastic Beanstalk will also know from where can it find the necessary Docker container. So AWS will have all of the necessary instructions just to run your application and scale it on the needs. So right now, as you can see, we will have not only, okay, let's do it like this and like this to make it more understandable. And if you're talking about the customers, okay, let this one be a customer. So whenever this one will have any requests, all of the requests will be landed on the load balancer, and then load balancer will make a decision. So which one should on which virtual machine and on which side of your application it should land this request. It may be a round robin approach or just whatever you choose. So maybe less loaded one or just whatever. So we're actually a bunch of options about it. And if you're talking about the scaling, sure, we can create another one and another one and another one. So we can just set the limits. And I think it's a good approach. So just to set limits to make AWS understand that, okay, we don't need to create more than 10 virtual machines within our application. And it will give us pretty redundant and fail-tolerant architecture. So in this case, we'll just fit in our code to the AWS and saying, okay, this is a Docker container I want to deploy. And then we will have also a bunch of options. So the amount of these virtual machines, do we need a load balancer, what kind of instances it should be. So if we have a pretty lightweight application, so it may be even stored on the micro or even nano instances, but it also may be something a bit more. And if you're talking about the scaling, so I think it's also worth mentioning, but we can even set up the options. So if we have a decrease in load, so for example, now it's not 10,000, but it's, for example, 2,000 customers or something like this. So please just get rid of not necessary virtual machines. And AWS will just simply do it. And all you need to do in all of this stuff is just run a few commands. So first one is something like eb init. So just to initialize your application. And then I can't recall this one. So, okay, let me Google that for my, bear with me for a second. Where can I find it? Okay, so actually it should be something easy. So something like the eb deploy, I believe. Yeah, it's eb deploy. So and then by providing the eb deploy and providing some necessary stuff, so something like pointing to the necessary container URL or to the Docker file, and specifying the application name and something like this. So AWS will make the rest. So we will just deploy your application and you will be provided the URL for your application, which can be accessible and highly available. This is how it looks like. So yeah, but sure, you always have an options. You can do it all of the stuff manually. But in this approach, as I believe I already mentioned this one, so all of the security patches, all of the updates on the underlying infrastructure, so in this case, it's just virtual machines, will be responsibility of the AWS. So we don't need just to do anything. We need just to deploy our application and that's it. Any questions? If not, I think we are good to have a look at our task, just to understand what should be doing this one. Okay. Docker and AWS Elastic Beanstalk. We will need to fork this application, but if you already did it in the previous task, so you don't need to do so. You will already have a working application. But you will need to create a Docker file. So I already shown an example, but if you will reach any LLM or just something like this, it will help you with a big pleasure to create this Docker file. Like, quite simple. You will need just to understand what's happening inside, because Docker is, I believe it's a quite interesting technology, and knowing it and understanding how it works and what can you do and what you can't do with it. So it's quite crucial for all of us. Make sure to perform the following steps. So add Docker ignore. Okay, just to minimize bulk context file folders generated by the application or npm should be excluded. Okay, makes sense. Provide explanations to why the folder was ignored. Okay, I believe you should provide just these explanations to yourself in this case. And then they have task number. Okay, it's too freeze in here. Pretty weird. Okay, I'll get rid from one of them. Okay, so and then you will need to minimize your container. And by minimizing, I mean is multiple stage building of the image. So actually it's the approach I shown on the slide. So where you're creating a Docker container and then building something inside of it and then just taking all of the necessary stuff to the next freshly created one. So it's quite simple, but yeah, it's actually a best practice. So just to make your image containers as lightweight as possible. Lint Docker file, so very special command, something like docker lint or something like this should be. Just to have a look if you succeed with all of the syntax constraints at the Docker file. And next, use the Docker file from previous subtasks to deploy your card service using AWS Business CLI. So yeah, as I already mentioned, so you need to run eb-init command just to initialize your application. And then, okay, it's eb-create. It's not eb-deploy. Pretty weird. Oh, no. Yeah. Okay. With eb-create, we are just creating an environment. So first of all, by running eb-init, we are creating the application. But this application actually may have a different number of environments. So it may be dev, QA, production, just whatever. And we need to do such environment by running eb-create and providing all of the necessary stuff to this command. And in the end, we will just need to deploy it. And then update commit questions. Oh, bear with me for a second where it was. Okay, yeah, here we are. So there is also suggested once you deployed your application to go and have a look at all of the EC2 instances, all of the load balancers, if there are any, just to try to understand what Elastic Beanstalk actually does inside the AWS. Because yeah, you can always just deploy your application and forget about it. But it's also cool, it always actually cool just to have a look on what's really inside of this application and on what it is, on what it's running on. So in case of Lambdas, yeah, it was a bit complicated just because it just functions and nothing else. But in this case, you will have the real virtual machines deployed for your needs. Okay, and once we are done with it, we will be provided with the URL, which then we need to provide to the front end of our application, to the API paths. So we will need to substitute the previous one, which been for Lambda function. Now we will need to put the new one from the Elastic Beanstalk deployment. And in the end, make sure application starts to call card service API when you add or remove items. That's pretty it. Commit to this per separate branch, create a pull request to the master, and provide it as a submission. Okay. So, evaluation criteria. First of all, is Docker files prepared, images building, image size and minimized to be less than 500 megabytes. I believe there is a command something like Docker image ls in the CLI, which will show you the size of your image. So I'm not sure if I have any. Let's have a look. I believe I don't even have a Docker on this machine. Yeah, just because it's Podman. Okay, it's not running. I don't know why. And Podman machine init. Try Podman machine start. Yeah, okay, sounds good. Maybe just because I restarted it. I restarted my PC, so. Yeah, Docker unfortunately doesn't have an open source license. So if you're using it for the commercial projects, you can just use Docker. Okay, you actually can use Docker image, but you can't use Docker desktop. So yeah, be careful with this one. So I'm not sure if I can install just Docker image on the macOS. So I just started the just installed the Podman, which is actually pretty the same, have the same syntax, same commands, but just named a bit different. So yeah, this is how it looks like. So bunch of images, most of them just known. Okay, yeah, and there is also an our application, which is 129 megabytes. So, and what is the necessary size? Am I fit on it? Okay, it's about, okay, yeah, makes sense. So, as you can see, it's possible. At least it's been possible 8 months ago. So, just let me know if there is something changed in the dependencies of our application. But if not, so yeah, you will have an option to build it. It's small as 129 megabytes. Okay, once this one is satisfied, so Docker file is optimized, files that change more often in command that depend on them should be included later. Files in command that change less should be at the top. Makes sense, yeah, at least it improves the readability and the understandability of how our image will look like after the build. Folders are added to the Git noise explanation. At least 2 big directories should be excluded from build context. Elastic Beanstalk application is initialized. Okay, and for this one, even if it's not deployed, you'll get 70 points. And there is an additional tasks. So first of all, we will need to create the environment. Okay, actually, yeah, in this task, we don't need to work with CDK. So all of the stuff should be done by ebcli command. So I believe there should be an instruction. Yeah. So how to install it. And okay, and just to initialize it, we need to have AWS configure already up and running on our machine. So, and now if our application is deployed, you should provide the link to your application to the with your pull request, and it will be additional 15 points. And 15 more if your application is finally integrated with the front-end part of your application. So don't rush this one just because you have 2 weeks, I believe, for this task, or it's only one left. Oh, I messed up with this schedule once again. Where can I have a look at it? So okay, and when will then it will end at the next week. Okay, so only 1 week left. So yeah, but anyway, take your time and just try to understand how the Docker works, and then just deploy this application, submit all the necessary stuff, and that's pretty it. Any questions at this point? Okay. If you don't have any, so I have also I still have some stuff to tell you. So first of all, this Friday we will have another workshop from the AWS. So this one will be dedicated Elastic Container Service, which will, I think during this workshop you will also work with the Elastic Beanstalk, and you will have a chance to understand how the container, AWS Container Registry and Container Service works. So how can you store your containers, how can you run your containers, how can you scale them, and what are the best practices about it. So it's not usually just EB init and EB deploy, so sometimes you need to do some other stuff. So for example, building and storing the containers and inside of the AWS and so on. And also there is this quick notification about this, about the previous, I believe, and this task. So just not to make any changes, and thank to your fellow student for mentioning it. So you will need to create, okay, how it was actually. So I already messed it up. So let me have a look. So we have different, okay, let me do it like this, and then like this, and then like this. Where is it? Come on. So yeah, if your application is not working as it should, so maybe you're missing something or is just partially answering all of the requests which have been done against your application. So don't care much about it, just because we are learning AWS in here. And if you will need to make any changes, so yeah, in the previous task we had an issue with we had an issue about the data structure. So how should we store it in the database, and how should we retrieve it from the database? So it's better to stick to the format which is already explained on the front end part of your application. So there are some changes maybe necessary from the part of the card service. But if it's not running as it should, and if you have any difficulties, so just don't pay much attention on it. Just because it's not AWS, so it's about application, and we will try to make this application to make it deployable as smooth as possible. So I don't have any TypeScript or Node.js experience, so it's quite hard even for me. So yeah, we'll try to do and implement something with it. But right now, yeah, and if you're checking someone's job and there is something is not working as it intended, so don't deduct so many points. So just talk with this person and try to understand if he clearly understood what has happened. Okay, and I believe that's actually it from my end. So yeah, workshop, and don't care much about the functionality of your application. The workshop will take place is the 10th of April. So yeah, actually it's this Thursday, no? Okay, yeah, it's actually April 11th. So the registration will close at Thursday evening. And also don't forget to do all of your cross checks. The deadline is Wednesday evening. And I think that's it from my end. Yeah, finally. So next time we will meet with you in a week, and it will be the last session, the last task. Not much complicated actually, but yeah, still need to do something. Okay, so if you don't have any questions, but if you will have any, feel free to ask them in the chat in the Discord. And at this point, thank you very much for your attendance. Thank you for being today in here. And thank you for your effort in this course. And see you in a week. Cheers.